I've been writing books for a long time. So let's go into kind of like the screen itself. So I started started my, I guess like really like the data career when I was working at Yahoo, working with like Hadoop back when Hadoop was like, cooler than Spark because Spark didn't exist yet. But kind of since then I've been more on like the side of like, kind of distributed systems and then like working with like massive streaming systems as well. So I worked with like Apache Storm before Spark came out, or I guess like it was out, but I hadn't heard of it yet. And I didn't really start using Spark until I joined Twilio back in, I guess it was like 2015-ish or so. But I think one of the interesting things about like most of these kind of, high intensity, like, data systems is like, there's simplicity that is kind of interweaved with a lot of that complexity. And so I guess you could say like for the past 10 years, like my career is really focused on making kind of complex things simple. And I think writing has helped a lot with that as well. And so I guess like, if we talk about who I am as well, like, right, it's like a mentor, teacher, author, also an engineer, but also like a cook. I make hot sauce as well, which, is not a moneymaker or anything else. I just do it for fun, test the pH as well because of botulism. But, trying not to hurt friends. I also enjoy adventure sports and kind of getting outside to sort of kind of, detox from, long work cycles and things like that as well. But, we're not here about me. We're here more, to find out about, what is that kind of future looking like for data engineers? Like, what is it that we can expect to see? What have we already seen as well? And so, if we think about right now, right, like we're embracing the now, like, you know, humans are doing a lot of the work and we're sort of, we're slowly kind of integrating, agents almost like in the way that you would sort of kind of introduce kind of like, not necessarily like junior engineers or anything else like that, but almost like, it's like, teens who are learning how to program, things like that. Like, when I was a child, I'm like, not even a child, as a teenager, I learned like C so that I could start figuring out how to, make video games. And it's sort of, you have kind of a different way of learning at that point in time. There's not really the stress of like the job, but I kind of, the way that I'm looking at like agents right now is like, we're kind of teaching that next generation how to how to work and how to kind of do the things that we've done before so that we can up level ourselves to do things that we actually want to do. And so a lot of this talk is kind of showing like a practical guide of how to actually use agents right now to kind of augment the way that you're writing your code. And then after that, it's kind of going into, what is MCP and things like that? What are kind of practical examples of that as well? But it's interesting because like I think between the time that Matt reached out and the time that, right now, there's been a ton of, changes in like the industry and tons of changes with like what, agents are able to do. And so it's funny because like, even if you're working on this stuff full time, you always feel like you're kind of playing catch up as well. Which is, there's pros and cons to all of that. I think it's, we're, now progressing at a very, incredible rate, which is very cool. And so, aside from that, if we think about, kind of classic data engineering and like the things that I have done for most of my career, right? We have data sources. Everyone's seen, something similar to this before, right? It's like, I've got streaming data, I've got data at rest or stationary data, and then I've also got, transactional data that I can look up as well. I've got jobs that are essentially, either working as a distributed compute or they're working as kind of localized compute. But at the end of the day, we're essentially saying, I want this work to be done. I want it to be done, essentially, in a very kind of specific deterministic way. And then I want something to be done as a result. Things will either fail or they will succeed. Hopefully they don't kind of semi-fail. And there's, in a lot of the different compute, like distributed compute frameworks like Spark and things like that, like there's ways of, getting around failure. But I think the more interesting thing right now is like, how do we augment like our day job? So if you're currently working as like a data engineer, the way that you're augmenting your day job is essentially by making your job a little bit simpler, right? Like there's a lot of things that can be kind of config driven, or you can create, frameworks around that let you focus on, essentially, transforming data from, shape A to shape B, or joining it with other data sources and things like that. And like, I used to work at a very large company called Nike, and like there's a lot of, if you have like 10,000 tables, you have 100,000 tables, things get a lot more kind of like interesting in terms of not being able to kind of manage that much complexity like on your own. And so if you have the ability to, easily get into like your catalogs to be able to find, data definitions, to be able to go get like, the DDLs or the schemas for individual tables, that's nice if you know how to do that really, really well. But it's also something that like an agent can actually really shine at as well. And so if we think right now about like the path to kind of like full augmentation or, kind of fully automated like data engineering, we're not there yet. Like there's a lot of really promising kind of like examples of how you can do that, but there's still a lot of domain knowledge that's really hard to transfer as well. And so Jessica had kind of gone over that, like with like the ontologies and like, going through the knowledge graph, like these are, very complex systems. We can think about like enterprise data in the same way as that as well. But if we think just about, how would I solve things and create a framework, essentially like really like we're focusing on just, how do we augment, kind of the work that is being done to transform from, shape A to shape B and to go and, actually, land data in a specific area. And this is not a talk about multimodal data. This is a talk essentially on like classic data engineering and sort of the shift that like I've been seeing over the past like year, as like, coding agents have become more of a thing that people are using kind of on a daily basis. And so it's like, what does kind of hybrid vibe look like for people nowadays, right? And so if we think about this, right, like, LLMs are good with language. We've already had like the talk from John Snow Labs about like natural language processing. Like, these systems understand our intent. And then, I think it was about maybe 7 months ago or so, it's like the first kind of reasoning models came out. And so like, I'm a big fan of Claude. Doesn't matter what you're using. Like there's a lot of really good like open models as well, like Quencoder, things like that as well. Um, and they understand the semantics of like the code that we create. And the interesting thing with that too is it's like, well, for me, I've been in this industry for about 20 years. And so like I have a good understanding of like, how to build frameworks, how to build generic applications. And so as long as my coding agent can understand my intent, then we can actually create better skills to be able to make sure that, things are being done in kind of more of a deterministic way, even though an agent will always be, more or less kind of non-deterministic. And so it's like the same thing, right? You prompt 10 times, 20 times, you're going to get 10 to 20 different sorts of results. Thematically, they're mostly the same. And I think that's where a lot of these frameworks come into place, where, I want something to specifically happen when I have a specific input. And so if I have a specific input that allows me to, say, go create new test files, or, take a look at like Astral's like UV and figure out how like the GitHub actions work. And that's what we're going to go through right now. And so if we have a framework, you can take a look at like this as well. There's a QR code. This is an example. It's fully open sourced. I haven't added a lot of like credit or anything else to it. Like I wrote this with Claude and myself over like maybe about like a 2-week period. But it's interesting, like introducing Claude essentially happened about like 2 weeks ago for this project. And it's interesting, like the things that it will learn. Like I'm just going to call it because there's instances of Claude, and I think a lot of people like to think about, is my LLM, human, etc. I like to treat it just like I would any other engineer that I'm working with, and explain things in steps. And so the framework that we're going to look at today is essentially like, if you think about abstractions, um, you know, as engineers, we create abstractions. And so if we think about, Spark being an abstraction over, how do we create, distributed, compute engines that do work on our behalf? Like, Scala Spark was brought up today. Java Spark was brought up today as well. Like PySpark was a kind of a simplification on top of Spark. And now I have another abstraction on top of PySpark as well that makes things even just a little bit easier. So you can kind of create configuration-based applications. And so if you think about like configs, like an LLM is very good at working with data. And so it's like, we think about a lot of like, what it is that we're kind of trying to build towards in the future, right? Like we know that we need to continue to write code. We might not be writing as much of that code ourselves, but we need to be able to ensure that we have like, the right guardrails in place so that the code that comes out of these automated systems looks exactly like what it would be if we were to write it ourselves. And so that's something that's going to be built over time. And a lot of that happens as like we're essentially creating, kind of on the fly context with Claude. So, essentially we're going to look at kind of like more of like not a one shot, but sort of like a procedural back and forth conversation that continues to make, better assumptions about the code that we're working with. And so if I think about, all of this, right? So LLMs understand code. That's great. Like MCP and agentic tools, can augment LLMs with real world skills, like, working as a data engineer or writing unit tests like in, Python, things like that. But given that the results are kind of non-deterministic, then that framework, helps a lot. And so if you've worked in like the Spark community, or if like you've taken a look at like Spark applications or anything else as well, there is a certain amount of kind of like non-determinism that becomes deterministic as, procedures are processed by what's called like the catalyst engine. And so if we think about like being able to write applications that continue to perform really well, we can kind of lean on the abstractions that the entire Spark community has created to be able to ensure that like what it is that we create continues to work as expected as well. And so if we take a look at this, right, like, so the streaming application, like the PySpark streaming base, is trying to simplify things as much as possible so that like an application can be understood by, like an agentic system, right? So if I think about Claude Code, for example, as an agent over, Anthropic's LLMs, like Claude wrote on the right-hand side, like the code, this was part of like Claude.md. And it first had to understand the entire code base to be able to actually write what it is that an application looks like. And it's interesting because like if you say, here's some random arbitrary code, take a look at it and then go build something that has, specific steps in it that will, create some sort of action that then, produces something on our behalf. If we think about, data engineering, right? Like we have an input, we're gonna do some sort of transformation, we're gonna have some sort of output, and that ends up being like what we commonly look at as like a data pipeline. And so if we think about these pipelines as something that can be essentially kind of, glued together through configuration, that is what, I find to be easier to teach, right now. If we think about trying to teach like Claude Code to use, a new, data engineering framework, for example. And so right now I have something called streaming app. If we have Spark configuration, and then we want to do some sort of, config overrides, things like that. Like people in the Spark community are used to using like Spark, config, the runtime config specifically to be able to, change the way that an application is working without having, anything that's essentially like hard coded within that app. And so if you're creating these frameworks that are essentially more config driven, then it's really easy to be able to then teach Claude or, Codex, anything else like, the actual configuration that it would need to be able to go and like wire up an entire application. And so really like, if we take a look like on the right-hand side of the screen where it says like run streaming query, df, sync options, etc. We have our query and then essentially, we're going to await termination. This is like a simple kind of like Spark structured streaming application. In between like running the streaming query and like the sync options, like we also, we have to think about like what it is that we want to do. We want to transform our data. And so like this example is not showing transformations, but it's showing how to teach Claude how to do a bunch of interesting things that will, lead to our ability to basically say like, the only thing I care about is a transform function that takes like my source data, does something with it, and then, writes it out to a sync. And so this would be essentially like an example of like our Spark config, right? So it's like, what are kind of like the, not necessarily the guardrails, but it's like, if we can teach, if I can teach Claude to write a bunch of config, then I can essentially, that becomes my easy problem, right? And so then that config essentially allows me to, auto wire most of the application other than say like a transform function. And so if we think about trying to limit the context, like we've talked a little bit about like context engineering over the course of the day today. And if we think about like, the ability to, fit a specific application in memory, like when I was working with Claude Code to kind of go over just this framework, I was easily kind of getting into like the 200,000 token window that I have with like my current version of like my, it's like the $20 a month Claude. I don't have the unlimited with like my own personal account, and that's okay. And so if I want to be able to continue to work with like these tools, then you have to think of ways of like, kind of simplifying things as well. Especially if you're not going to do, any sort of like, custom optimizations on top of, your agents themselves. And so if we think about this as like, learning on the fly, we're going to go through those steps in just a sec. So anyways, the big point is that like, if we keep things config driven, it's very easy to kind of create like the structure of an application or even test those applications as well. And so like one of the things that came out like when I was working at like Twilio and then I was working at Nike was like this notion of like, streaming applications having like, checkpoint information. That checkpoint information for a streaming application keeps track of the state of an app and where that app is. So that you can, essentially version your application, release new versions without, corrupting checkpoints or corrupting kind of, the past history of that application. And so like there's certain patterns that, you can take a look at if you want to go through the source code that make it really easy to not, collide Like streaming apps are great until someone else deletes your checkpoints and then you have to start over in a different way. And you don't sort of want those things. And so it's like there's certain tips and tricks that we can write into frameworks that then can be used by agents that allow them to really understand, why we're making decisions, but without having to necessarily teach it, the exact why for that. And so if there's certain steps that are like more complicated, or you have like, the output of like working with an agent is an application that's unstable, then it's, a good kind of point to the, kind of backtrack and think about like, what is it that you want, the coding agent to do and to be, knowledgeable of. And so, especially like in the Spark community as well, like you think about like the complexity of like, like Spark over the years. Um, while Claude Code is very good at understanding how Spark works, which we'll take a look at towards the end of the presentation, um, it's not going to necessarily understand every pattern for how to, operate things like in production as well. And then Matt was talking earlier as well. Like I worked on like the Delta Lake definitive guide with like Denny Lee and Tristan and Robert Corey and Prashanth. That maybe like about a year and a half ago or so. I think we just hit like the 1 year anniversary for that book. But like I know a lot about Delta Lake, and I found out also that Claude knows a lot about Delta Lake, which is interesting. So I like it's nice like to be able to kind of go back and forth and then teach it some new tricks or have it teach you some tricks as well. But if I think about like having an individual like a source of some sort, so in this case like a Delta streaming source, like it's just a table, right? And that table has specific options to be able to throttle to not throttle. And it's interesting because if you think about like teaching an agent, like what does productionalization look like? It's nice to be able to provide it with contextual comments and other information directly in your source code for it to be able to kind of build up its own working knowledge as well. And so like if anyone's used like Claude Code before, we basically just like kind of initialize everything, creates our Claude like MD, and it gives us kind of like a starting point for like the understanding of like a specific application, right? And so I'll kind of skip over this part. Like if you've used Spark before, if you use like the Delta syncs before, it's it's fairly easy to kind of set up. Like I think the bigger change is essentially the way that you kind of auto wire your applications. So if you want to turn on triggering or turn off triggering, or if you want to change the way that an application processes like micro batch data over time, that stuff is all things that are configurable that can then kind of augment the behavior of your app. But we don't have to teach Claude why and when to do certain things. But if we were to say like hey, we want to run like a triage job, and that triage job needs to be able to go back in time to, earliest checkpoints, or going back to like an earlier version of like our, Delta Lake table, or you do the same thing for Iceberg as well. Then it's like, you can kind of walk the agent through the things that you would need and then have it essentially spit out like a job config as well, which is kind of nice. And so I'll skip through this part and we'll take a look, basically just like kind of at the end of like the framework itself. So essentially it's just a simple wrapper on top of PySpark. That allows you to do like configuration driven like development, which is essentially kind of like the world that we're kind of moving towards, where, context is king. Our ability to provide like an agent with, specification of what it is that we want to do is important. But also like, there's going to be, I feel like kind of more and more of these like, kind of base applications that, if you need to be able to have like a deterministic output, you can use, and or, if you don't need that, then you can essentially kind of vibe your way all the way, to the top.